Hello, my name is Dr. Steele, and welcome to Steele Mathematics, where lessons in Algebra 1, Geometry, Algebra 2, Pre-Calculus, and Calculus are taught. And today, I'm going to talk about finding normal distribution probabilities. These are probabilities derived from the normal distribution. But first, I want to briefly discuss the normal distribution. What you see right now on your screen is the normal distribution. Some people call it the bell curve. The number on the bottom, or should I say the numbers on the bottom of the chart, are your z-scores. Those are the number of standard deviations above or below the mean. If the z-score is 0, that is the mean. So now with that being said, I want to talk to you about three basic probabilities. This is known as the empirical rule. Now, what is the empirical rule? 68%, or should I say about 68%, fall within one standard deviation. That means about 68% are between one standard deviation below the mean and one standard deviation above the mean. Secondly, about 95% falls within two standard deviations. That means 95% of the data falls between two standard deviations below the mean and two standard deviations above the mean. Finally, about 99.7% falls within three standard deviations. That means about 99.7% of the data falls between three standard deviations below the mean and three standard deviations above the mean. So the empirical rule, you just remember three numbers: 68%, 95%, and 99.7%. Now, the next thing I want to show you is what we call the Z table. And this Z table gives you more specific probabilities. So what you see right now are the negative z-scores. And all these probabilities, all those decimals that you see inside, those are probabilities that the data is below a certain z-score. So as you can see, it says the probability that z is less than a. So now I'm going to show you how to use this Z table. Let's say you want to find a probability that the z-score is less than negative 2.54. So what you do, you look at the row that has negative 2.5 and you look at the column that says 0.04. Negative 2.5 plus 0.04 is negative 254. And where they intersect at is your probability. Therefore, the probability that the z-score is less than negative 2.54 is 0.0055. Next, the probability that the z-score is less than or equal to negative 0.96. Now, let me say this. The difference between less than and less than or equal to is so minute, it's fair to say that you could just ignore the or equal to part. You're still going to just use the chart. So, to find the probability, you look at the row that says negative 0.9, and you look at the column that says 0.06. Negative 0.9 plus 0.06 is negative 0.96. And where the row and the column intersect at is your probability. So as you can see, the probability is 0.1685. The probability that z is less than negative 1.21, the negative 1.2 column, and the 0.01 column. And their intersection is at 0.1131. Therefore, that probability is 0.1131. The probability that z is less than negative 3.30, as you can see, is 0.0005. So all you need to do when you're using that z-chart to find the probability that something is, the z-score is less than a given z-score, you just look at the row and the column and see where they intersect at. Now, this is the negative half of the z-score. Now let's look at the positive half. So as you can see, the probability that the z-score is less than 1.62 is 0.9474. The probability that the z-score is less than 2.39 is 0.9916. Always pay attention to where the row and the column intersect. The probability that z is less than or equal to 1.81 is 0.9649. The probability that z is less than 3.15 is 0.9992. So again, when you use the z-chart, you look at the row and you look at the column. And where they intersect at is the probability. Now also keep in mind that the z-chart only shows less than. So how do we find greater than, or which two z-scores between? If you're looking for the probability that the z-score is greater than A, then all you got to do is look at the z-chart, and whatever you get, subtract from 1. If you're looking at the probability that the z-score is between A and B, all you got to do is look at your C table, find the two probabilities, and subtract. That's what this is saying. So with that being said, let's look at some examples. Let's say you ask to find the following probabilities. Round to the nearest 10,000. So you're looking for the probability that the z-score is less than 1.34. So all you got to do is look in your z-chart and look for 1.34. And that probability will be 0.9099. All right, number 2, you're looking for the probability that the z-score is between negative 0.01 0.45 and 1.12. So you're going to be looking for two probabilities. The first probability you're going to be looking for is for 1.12. And that probability is 0.8686 minus, now you're going to look for the probability for negative 0.45. So we're going to look at our chart for negative 0.45. And it would be 0.3264. So now that you found your two probabilities, all you got to do is subtract them. And you will get 0.5422. So that will be your solution. All right, number 3, you're looking for the probability that z is greater than negative 1.35. Well, since this is greater than, you're going to find the probability for negative 1.35. You're going to subtract it from 1. So let's look for negative 1.35 in your z table. And you would get 0.0885. And then you do 1 minus 0.0885, and you would get 0.9115. And that is your solution. The probability that the z-score is greater than negative 1.35 is 0.9115. All right, so let's say the mean composite ACT score is 20.8 and the standard deviation is 5.8. The ACT scores are normally distributed. Find the following probabilities, round to the nearest 10,000. All right, so you look at for the probability that X, the score, is greater than or equal to 28. Now notice, they give you the score, but they didn't give you the z-score. So the first thing you have to do is you're going to have to convert your raw score into a z-score. You do 28 minus 20.8 divided by 5.8. So if we do that, the z-score will be 1.24. Now, if you notice, I rounded the z-score to the nearest hundredth, because if you look at the z table, they only give you the z-scores rounded to the nearest hundredth. So now we got the probability that the z-score is greater than or equal to 1.24. It's greater than, therefore, you're going to find 1.24 in the z table and subtract from 1. So let's look at the z table to find it. and you have 0.8925. Therefore, 1 minus 0.8925 is 0.1075. Therefore, the probability of scoring a 28 or above on the ACT is 0.1075. Number 5, they're asking you for the probability of scoring between a 20 and a 30. So what you're going to do is you're going to have to convert two raw scores into z-scores. So for 20, this is 20 minus 20.8 divided by 5.8. And you will get negative 0.14. And then we're going to do 30. So 30 minus 20.8 divided by 5.8. Divided by 5.8. And that will be 1.59. Now again, you want to round your z-scores to the nearest hundredth because the z-table only gives the z-scores rounded to the nearest hundredth. So now you're going to look at your z-table, you're going to find two probabilities, and you're going to subtract them. So let's find the probability for 1.59. And that would be 0.9441 minus, now let's find the z-score for negative 0.14. So we got negative 0.14. And that will be 0.4443. So now that we found the two probabilities, all you got to do is subtract. And you would get 0.4998. So the probability of scoring between 20 and 30 on the ACT is 0.4998. All right, number 6, you're looking for the probability of scoring above 34. So the first thing you do is you're going to convert 34 into a z-score. So 34 minus 20.8 divided by 5.8. So 34 minus 20.8 divided by 5.8. And you will get 2.28. So now, this is greater than. Therefore, after you look in your z-table, you're going to subtract that probability from 1. So let's look on the z-table. And you will have 0.9887. And 1 minus 0.9887 is 0.0113. Therefore, the probability of scoring above a 34 on the ACT is 0.0113. So now let's take a look at these two examples. It says here the average wingspan of a bald eagle is 6.7 feet and the standard deviation is 0.8 feet. What is the probability that the wingspan is below 7 feet? Round to the nearest thousand. Okay, the probability that the wingspan is below 7.1 feet. So what you may want to do is you want to write it out first. This is the probability that x is less than, since it's below, 7.1. So next, we're going to convert that raw score into a z-score. Take the number, subtract the mean from it, and divide by 0.8. So 7.1 minus 6.7 divided by 0.8. And that would be 0.50. So now we're going to look in the z-table for 0.50, and you would get 0.6915. Therefore, the probability that the wingspan is below 7.1 feet is 0.6915. Now look at number 8. It says, what percent of the bald eagle population is above 5 feet? Round to the nearest tenth of a percent. So watch this now. They're asking for a percent. But still, we're going to write out what this means. Above 5 meaning the probability that x is greater than 5. We're going to convert this into a z-score. By subtracting the mean from it and then divide by 0.8. So 5 minus 6.7 divided by 0.8, and you would get negative 2.13. Remember, always round your z-score to the nearest hundredth, because that's what the z-table gives you. Now, since this is greater than, the probability you're going to get on the z-table for negative 2.13, you're going to subtract from 1. So let's look on the z-table for negative 2.13. And that is 0.0166. So therefore, 1 minus 0.0166 is 0.9834. So we found the probability, but they want it as a percent. That means we got to convert this decimal into a percent. And to do that, you move the decimal 2 places to the right. And then round it to the nearest tenth of a percent. Therefore, that percent is 98.3%. Therefore, 98.3% of the bald eagle's wingspan is above 5 feet. So what we have learned today was the use of the z-chart. And basically what you are doing is, if it's not a z-score already, you're converting raw scores into z-scores. Then you look in the z-table for populations. You're going to have to decide whether you keep the probability, subtract the probability from one, or subtract 2 probabilities. I hope that you have a wonderful and blessed day.